Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 19 in our incredible new series of tutorials where you are building a 9-axis inertial measurement system. What I'm going to need you to do today is pour yourself a nice big mug of iced coffee and get ready to do some pretty cool stuff. What we're actually going to do today is we're going to begin to animate our Vpython visual using live data coming from the BNO 055. So what I will need you guys to do right now is I will need you to call up that program that we left off with in lesson number 18. And just as a reminder, where we left off is we left off with this visualization where we kind of have a mock-up of our breadboard, our BNO 055, and our Arduino Nano. If you guys don't have your gear yet, look down in the description and I've got links where you can pick this stuff up. But right now this visualization over here is just based on a for loop where we're generating a yaw, a changing yaw for a given pitch, just to make sure that we've got our trigonometry in our visualization working. But the exciting thing that we're going to do today is we're going to begin to take the live data off of this system and do the animation based on the live data. So in order to do that, what I believe I will need you guys to do is go back to www.toptechboy.com and yeah, let's see, which lesson was that? That was lesson number 10. Okay, in lesson number 10, remember that is where we were, we kind of took 10 lessons to get to the point that on the excuse me, on the Arduino side, we could simulate, kind of approximate roll, pitch, and yaw. And we had that done in lesson number 10. So I need you to go to lesson number 10 and get this code that we had developed here on the Arduino side. So we got to kind of start with that works. So I'm going to go to www.toptechboy.com, 9-axis IMU, lesson number 10. Come down here and let's grab this code. Normally we don't copy and paste code, but we don't want to redevelop this. And if you guys have gone through the lessons, you've already done this. Now we need to open ourselves up a nice Arduino window, a nice fresh Arduino window. Let's see, I'm just going to do a new, okay. That should be good. Get rid of some of these other windows. Get this up where you can see it. Okay, that looks pretty good. Now I will just do a Control A for selecting everything, a Control V to paste what we just did. Now remember, as we developed this lesson, we were doing a lot of different I've lost my mouse. There it is. We were doing a lot of things as we developed it. So we were printing out everything from the raw acceleration data to calibration parameters. But if you remember the roll, pitch, and yaw that we ended up with, that we were actually using, that were the compensated and the filtered and the best kind of that we could do at the time, was the theta, the phi, and the psi. And so this is pitch, and this psi, this phi, what is it? Psi is yaw, and phi is roll, and theta is pitch. And so this is kind of like pitch, roll, and yaw. Okay, so what we want to do is we want to clean this code up a little bit, because I don't want all of these different things to send over, because they're really not doing me very much good. So I'm going to eliminate the X, Y, and Z acceleration, because I don't really need those anymore. The accelerometer, the gyro, and the magnetometer, those are calibration numbers, right? Those are our calibration numbers. I think I'll send those over, but the stuff before that I'm going to take out. And now the accelerometer calibration, the gyro calibration, the magnetometer calibration, and the system calibration, I think I will send those 4. And then these were various things along the way. And so I will come all the way down and just keep phi, theta, and or I'm going to take that out as well. So I will keep theta, phi, and psi. And so I'm going to get rid of those. Now, to make things easier, I'm going to send theta, phi, and psi first. And so I want to send it in the order that logically we usually say it, like roll, pitch, and yaw. And so let's send phi first, because that's roll. So I'm going to cut this. I'm going to put it up here. Okay, so now that is sending roll. And now let's get pitch, which is right here. So we'll cut that. So that is pitch. So I've got roll. And then this is pitch that I am sending. And now the final thing is yaw. Okay, I'm going to take the print ln off there because it's not going to be the last one anymore. And I'll put the print ln here on the calibration numbers. I'm going to go ahead and send the calibration numbers because as we're tweaking the thing, we might want to look at it over on the Python side. But I'm sending it last so we can just kind of ignore it unless we really decide to use it later. So let's get here the yaw. So I'm going to cut, roll, comma, pitch, comma. Did that wrong, but I will cut this, right? Cut, or Control V. Okay, so I'm sending roll, comma, pitch, comma, yaw, comma, and then I'm sending the data on the calibration. And just to remind ourselves, it looks like we are converting everything to degrees. So we've got to remember when we get over to the Python side that we are working in degrees. Does that make sense? Let's download this and just make sure we haven't broken something. Okay. Looking like it's happy. Okay. Please download. Please download. Still got the little green bar. I don't know why it's okay, it's happy. Now let's just take a quick look at the serial monitor, make sure that things kind of look good. Okay, we got data coming, and then if I swing it around, the numbers are changing and the numbers look like they're in degrees. So if we didn't break anything, then we should still be in pretty good shape, I think. Okay, so that is the Arduino side. Make sure that you close this window or you will not be able to grab it in Python. Okay, so now on the Python side, I am just going to get rid of all this stuff because that is just nonsense. Okay. All right, so we are starting now with a fresh, clean Python window. Let's see. I'm trying to get down here to... Okay, got my interpreter line, got a nice fresh window. All right, let's go back to where we left off in lesson number 18. So we will go back to www.toptechboy.com and we will go to lesson number 18. Hopefully we will find here lesson 12. Okay, there it is. Non-axis IMU lesson number 18. And then this is the code on the Python side. Okay, so I'm going to do a Control C. And then I'm going to come back to Python. You guys remember we moved to PyScripter from idle along the way. If you haven't done that, go back and look at that lesson because I think it's a lot easier to work in PyScripter than the idle. Python's the same, it's just the editor that we're using. Okay, so now we have this in here. So I need to do a Control F2. That kills a program. I had another program running in another tab. So Control F2 will clear the old program. Okay, so let's run this thing up here with the little run button and let's see what we get. Okay, boom. So this is the animation that is just based on generating data to see if our orientations and our geometry and our trigonometry are right. So that looks good. I do believe that that is working. So now what we need to do is with this instead of just making up data, we need to go and get the data from the Arduino and use that to make our animation come alive. Okay, so how will we do that? Let's look at this code, and we have kind of a for loop here, and we're not going to want that for loop anymore. So, and we're not going to want to just set a fixed pitch, and so we're going to take those two lines of code out. All right, and then what we do want here is we want to go get data. And so we're going to have to come up to the top, and we're going to have to do a little bookkeeping to set up that serial port. So besides the other things that we are importing, we are going to need to import serial. And if you've watched the earlier lessons, you should already have put in PySerial, installed PySerial, so this will work then. Okay, and then we need to open our serial port, so I'm just going to call it AD for Arduino data. You know, when you got to do a lot of this, sometimes using something shorter, like it would be good if I called it Arduino data, but I'm just going to call it AD because it'll be less typing later on. And to turn the serial port on, do you remember it is serial dot serial? Okay, serial.serial. And then my Arduino is on COM5. Okay, you've got to put in where your Arduino is. Okay, so like if I come over here and I do a tools and I look down here at the port, I'm on COM5 on the Arduino side. So you need to use whatever COM port you are on. I am on COM5, so single quote COM5. And then if you remember in that program, what baud rate were we working on? In the void setup, 115,200. Sometimes I just copy that just because I can. Siri, go away, Siri. Hey, Siri, go away.
Sorry, just trying to help.
Well, you're not very helpful, okay? Now, no more interruptions. I don't know if you have that problem. Okay, so where were we? The baud rate. I put the comma on the wrong side. Come over here, comma, and then the baud rate. So that should turn on the serial port. And when I do that, I like to do just a time.sleep of 1 second to give the serial port time to initialize. And I think maybe it's just a sleep time the way we're doing it here. I get confused sometimes on that command, but if it doesn't work, we'll come back and fix it. Okay, so now we've got the serial port turned on, so we come back down here. Now we want to go out and we want to grab that data. Remember on the Arduino side we were passing the data, now we got to catch it. So what's the first thing I want to do? Well, while okay, AD Arduino data. Let me make sure on that. While Arduino data dot in waiting. Pay attention to my capitalization. In waiting. Arduino data in waiting equals 0. Okay, and sometimes I never remember if it wants the parentheses around the conditional or not, but I will put it there just to be safe. And then we put in a colon to start our while loop. So while Arduino data in waiting is 0, that means while there is no data there, what do we want to do? Absolutely nothing. We want to pass. Okay, now this is where we would begin to read it in. And so what I want to do is I want to say that my data packet, this is that whole string that I'm going to read in, is equal to Arduino data dot read line. Okay, Arduino data dot read line, like that. Okay, so now I have that string. I sit and wait until there's data, and when there's data, then I read the string all the way up to the println. Okay, so now what I can do is that if you remember that with this new version of Python, it puts that /b and some characters that cause us problems, so we need to take those off. And so that's data packet is equal to the string function on data packet, and then what do? I do this UTF-8, and that gives it a format that will take that nonsense off that causes us problems. Okay, and if you went back, whatever this lesson was, I explained it, so I'm not going to go into it a lot right now. And then what we can do is we can say that now that's a big string, so we want to create an array, and we want to split the string at the commas, and then each position in that array would have a different number. So now I'm going to call this array split packet, and that's equal to data packet dot split. Okay, and then where do I split it? I want to split it at the comma. I can't remember. Split it at the comma. All right, so data packet is the string we read. Split packet is an array that we're creating. That array will be populated with the numbers from that string split at the comma. But if you split a string, you end up with strings, so we got to remember that split packet is an array that has strings in it. Okay, now what we can do is we can come in and we can create, remember we sent roll, pitch, and yaw, so roll is the first one that we sent, so roll is going to be equal to, we're going to float it because it's a string, we're going to turn it to a float, and then it is split packet. And which one is it? It's the first one, which is the 0th position. Okay, and now I can just copy this, Control copy, and then I'll just do a Control V for paste, Control V. So the first one was roll, pitch, and yaw, and roll was the 0th one, pitch will be the 1, and split will be, or float or yaw will be 2. We also have to remember, that we are sending these over as in degrees. And as we start doing the geometry and the trigonometry, we really want them in radians. And so let me look up here, and if you remember on this code, we had this 2 radian conversion factor. So if I just multiply those by 2 rad, that should make them in radians. So times 2 radian. I will copy that. I will paste it. And I will paste it. Okay, so I should have roll, pitch, and yaw now. Now you see, because I took out that for loop, all the rest of this nonsense is indented too far. So I need to select it, and I need to come up to Edit, and then Source Code, and then I can unindent the whole block, and that should make everything good there. Wow. So let's see. So now I'm getting roll, pitch, and yaw from here, and then my old program was using roll, pitch, and yaw for made-up numbers. So it very well could be that there's something I'm not thinking of, but I'm going to go ahead and try to run it, and then we'll clean it up. I will need you to hold your breath this time because this one is going to be rough. And also, I have another program running, so I need to do a Control F2. If you ever look up here and your little green arrow isn't active, it's like you still have an old program running, so you've got to kill it. Yes. And now the little button comes back. Hold your breath. Yes. Okay, so let's swing it around, because remember we need to do that to get it calibrated. And let's come back over here and look at this. Hey man, boom! It looks like this thing at least is trying to be alive. Now you remember my red axis was north, and so I'm going to try to arrange this thing where north in my virtual world is pointing towards north in my real world. And as I rotate this, you can see that it is rotating, but you can also see that the yaw that I am getting from this thing is kind of like the yaw is not lined up with the physical world. And so let's come over here and see if we printed that out on the Python side. So I don't believe we ever put a print in here. And so I think what I am going to do is I am going to put a print in here just so we can kind of see what our data is doing. After we got our data, I'm going to go print. And I'm just going to print the roll, pitch, and yaw. I guess I would need to go back to the degrees just because it's easier to understand degrees. And so I'm going to say roll equal, comma, roll. Oh, I am really messed up here. Somehow I hit the up key. I have one of these doofus little keyboards because my desk is so crowded, and without a cord it's easier to get it in and out of the way. But the problem with this silly thing is it has a tiny shift key, and then right where you expect the shift key to be, there's an up arrow and a print screen, and so you're constantly hitting the wrong thing. So that is the problem, and that's what I just had. So yaw is float split packet 2. Okay, that looks good. So then we are going to say very carefully pitch equal, and then that is going to be equal to pitch, and then I think I need to put a space before P so that we get a little room in there. And then we are going to say yaw equal, and then we are going to put yaw. All right, now we need to go 2 degrees on this as we print it. So we're going to say edit copy, and so we're going to come down here and we're going to print it in degrees. And so I'm not going to change the variable back to degrees, but I'm just going to change it with the 2 degrees in the print, so that so I'm going to say times 2 degrees, and then I will copy this, and then I will fix pitch, and I will fix yaw. Okay, so let's do a Control F2 to kill the old running of the program. And now let's go like this. Okay, so I want to come back to that PyScripter. Okay, so now again, since we started again, we got to get those magnetometers going. Okay, so now what you can see down here on yaw, in the real world, here in the real world, what I have this front vector I'm calling the front, and so it is putting it at 180 degrees. Okay, so what the BNO 055 is, it's calling this direction north. Okay, so I could rebuild the circuit where this was turned around, and so it would then match what my geometry in Vpython is. But what I'm going to do is I'm just going to add pi to it, because if I add pi to the number being read, that will be the same thing as switching it. It's just easier, I think, for me to add pi. So you understand, when I set this up, in all my calculations, I said this is the front direction, but the sensor is saying that this is the front. And so I can just adapt that by adding over here on this side. So where we read yaw, where was that? Okay, yaw is equal to this. I'm just going to say plus np.pi. So I'm just going to add pi to it. I think that should work, but we will look and see. So we'll do a Control F2. Yes. Okay. And now let's run it again. Okay. So now let's swing it around to kind of get those magnetometers calibrated. And guys, we kind of got comfortable where we could calibrate the magnetometers. Okay. Now this darn thing, Okay, I see. Now, remember, red is north, so I'm going to just swing. I'm just swinging the camera around. I'm not doing anything other than swinging the camera around. And so north is that direction, and then here in the real world, north is that direction. So now my vector here in the real world is pointing north, and in the simulation it is pointing north. Now it looks like I have a little tilt in there, but I really don't. Okay, so far we have got it where it should know yaw and it should know pitch. We have not dealt with roll yet, but let's do yaw. Boom! Do you see that? Live data coming from the BNO 55. Nose up. Okay, I get too excited sometimes, and then I don't know if these things are in view. Okay, so we're going to go. Remember, this is our nose. Nose up, nose down. Okay, yaw towards the east. Okay, yaw back to the north, yaw to the south, and then back there. Look at that. Okay, now let's see. This seems pretty good up to about 45 degrees and minus 45 degrees. Remember that we made a lot of trigonometric assumptions, and so probably we're going to expect things to break as we try to go to vertical. Okay, this one seems like it will almost go to 90. Okay, it will almost go to 90. Okay, that's kind of interesting. Things are going to get more complicated when we put the roll in. Okay, it does kind of do at 90. It does round thing, and we'll step that we've been able to look at that. We've been able to get a simulation with yaw and with pitch. Okay, what we have to do next time is we're going to have to deal with roll. Okay, we're going to have to deal with roll. And I will come back next time and I will kind of explain that. But at the end of next lesson, we should be able to not just have yaw and not just have pitch, but we should also have roll. So you see right now when I roll, it's not seeing it because we haven't built that into the math. Okay, this has kind of been a fun lesson. Hope you guys are playing along at home. If you're enjoying this, give me a thumbs up. Love to hear your comments. I read every single comment, and I can't respond to every single comment because there's over 100,000 of you and only one of me, and so I really can't help you debug your code. But I wish you guys would read each other's comments, and maybe some of you could help people that are getting hung on things, those of you that are going along. Let's try to get a little bit of a community going here. And believe me, I would help you individually if I could, but it's just I get hundreds of emails every day, and I can't sit and I can't debug everyone's code because I actually have a real job, right? And this is just kind of a little bit of a hobby on the side. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.